Okay, let's take a look at the problem on slide 18. I'm given an atom of lead, and the symbol for lead is Pb. It has a mass number of 207, and I am asked to find the number of protons, the number of electrons, and the number of neutrons. Okay, if we look up the element of lead, so Pb, in the periodic table, you will find that its atomic number Z is 82. And by the way, this is the typical notation that we use to write atomic numbers and mass numbers for what we're doing right now. In general, if my element is X, then I will have A as my mass number on top and Z, my atomic number, at the bottom. Remember, the larger number is the mass number. The smaller number at the bottom is the number that you find on top of each element symbol in the periodic table. So these numbers go the larger one on top and the smaller one at the bottom, just like I did here for lead. Now, Z, we said, is the atomic number, and it tells us how many protons there are in that particular element. Lead is number 82, Z82, which tells me that the number of protons has to be 82. Now, because this is a neutral atom, it's not an ion, that means that the positive charges are balanced by the negative charges, which means I have the same number of protons as I do electrons, which means electrons have to be 82 as well. Now, when I go to figure out N here, I will write this over here real quick. So I have 207 lead and 82. To figure out the number of neutrons, I know that the number of neutrons are calculated by subtracting the atomic number Z from the mass number. The mass number includes the number of protons and the neutrons, whereas Z only has the number of protons. Therefore, the easiest way to do this, if you write it in this notation, just do the difference between the top number and the bottom number. This is A, and this is Z. So you're subtracting Z from A. This is 5, this is 2, and this is 1. So lead would have 125 neutrons. That is how you calculate that. Once again, the electrons and the protons are not that difficult. We figured that out. They are equal in a neutral atom. And then the number of neutrons is always calculated by taking the mass number and subtracting from it the atomic number Z. And if you, like I said, if you write it in this notation, just take the top number and subtract the bottom number from it to get the number of neutrons. That means that you have to have the larger number on top. That way you always remember to do it correctly. Let's look at the ions. What if you have O2 minus and Al3 plus? This is oxygen ion, and this is the aluminum ion. Okay, oxygen, if you look it up in the periodic table, has a Z of 8, whereas aluminum has a Z of 13. Okay, so the Z tells me the number of protons. So let's do number of protons, number of electrons, number of neutrons. If I have a Z of 8 for oxygen, that means that I have 8 protons. Because now it is not a neutral atom, it is a negative ion. The negative here tells me I have more electrons than I do protons, and the number tells me how many more. I start with 8 electrons, but I have 2 more protons, which means, I start with 8 protons, but I have 2 more electrons, which means that I will have 10 electrons for for the ion of oxygen. And then to figure out what the number of neutrons is, if you look up the oxygen, it's 16. So 16 minus 8 will give me 8 electrons, or 8 neutrons with no charge. So the mass, the atomic mass of oxygen is 16. My Z is 8. So if I do A minus Z, just like I did for lead, 16 minus 8 gives me 8, which is 8 neutrons. Now let's look at aluminum. Aluminum has a Z of 13, which means that the number of protons will also be 13. Because I don't have a neutral atom, I have an ion. I have a positive ion, which means I have an excess of protons as compared to the electrons. And the number here tells me how many more protons I have versus electrons. So if I start with 13 protons, and I know that I have 3 less electrons than I do protons, or 3 more protons than I do electrons, then all I have to do is take 13 minus 3 gives me 10 electrons. If you add these up, this is plus 13 minus 10 gives you 3, so 3 plus as a charge. You've done it correctly. And then if we use, and I'm going to just pick approximately a number for aluminum. So if we do 27 as the, so let's do Z of 13 here, and 27 as the mass, the atomic mass for aluminum. To calculate the number of neutrons, all you have to do is subtract the bottom number from the top number. This is Z and this is A. 7 minus 3 is 4, and 2 minus 1 is 1. So I have 14 neutrons in the atom or ion of aluminum. This is how you can work through these types of problems. If you know the Z, you know the number of protons. If you have a neutral atom, they're equal to the number of protons. So electrons and protons are the same. If they're not, if you have a negative charge, that means you have that many extra electrons than you do protons. If you have a positive charge, you have that many less electrons than you do protons. And then to calculate the number of neutrons, you take the Z, the atomic number, and you subtract it from the atomic mass. Typically, the atomic number in the periodic table is above the element symbol, whereas the atomic mass is below the symbol. And they're backwards there, but in this notation, remember that the larger number, which is the mass, is recorded on top, and the smaller number, which is the Z, the atomic number, is at the bottom. Okay, I once again will erase this, and then we'll continue on with the next problems.